We're live. Welcome, welcome. Almost. Now we are. Welcome, everybody, to the 41st episode of the Swift and SwiftUI Learnalong. I am your host, me. And you're going to have to bear with me. I got to catch my bearings after a few days of being away. Matter of fact, well, no, it hadn't been a week. Yeah, not quite. Maybe 5 days. But I said we would continue this, and we will, even if it has to slow down to a weekend thing. But thankfully, this is the holiday. So we're going to take advantage. But, yeah, shoot, where to begin? Well, let's start by, first we will open Xcode. We'll learn how to open Xcode. No, I'm kidding. No, we'll get there quickly. But before we do that, let me step you through the rigmarole of what this is, what you're looking at, yada yada. Okay, so just to get you caught up on where we stand, if you want to get caught up, we started by learning the Swift programming language, and we did that the same way we're doing SwiftUI, which is I buy some book or course that I find appealing, that appeases what I want to learn, and then I narrate that to you. And the nice thing about the book that we're currently on is they encourage content creators to do that. Not all of them are crazy about that, but it's totally legal, bro, so don't worry. All they ask is that we give them a shout out, so we will do that here in a sec. But if you want to get caught up on what we've done so far, there's 46 episodes, which is about 130 hours-ish of streamed content. It's all linear, labeled by episodes. If you want to get caught up on Swift, the general purpose programming language, you can do that by going to YouTube and subscribing to this YouTube channel, Nico X Narration, and just go to the live section, and all the past recorded streams are there. So everything up through episode 46 is going to be going in sequence through a book called Swift Programming, the Big Nerd Ranch Guide. So Big Nerd Ranch, if you haven't heard about them, they are a great source for literature and courses around technical things. That's the best way I can describe it. So they have a lot of great books and stuff if you want to learn about something else that's technical, like say Rust, or actually I don't know if they have a Rust book, but anything you want to learn that's technical, I would check out their website or look for their material, because their method of teaching I really like, I really enjoy. And I think it's good for beginners because it's very nuanced. It does not make an assumption that you have a computer science degree ahead of reading their book like a lot of courses do. So, and yes, I'm throwing shade a little bit, but it's true. It's a thing that is out there. So check out Big Nerd Ranch and check out the YouTube channel if you want to get caught up. Now, where we currently stand is we're in the midst of learning SwiftUI, so shout out bigmountainstudio.com. So let's go there real quick, because that's part of the deal. So they were nice enough to say directly in their material, hey, if you're a content creator, we don't mind if you use our stuff. Just shout us out. So that's what we're doing. But in all reality, too, I mean, I personally, like here on this stream and in my continued journey of learning Swift, I will be back to purchase more things. I can say that for a fact because right now, let me just show you which one that we're going through right now. We are doing, is it that? No, it's not that one. It is, which one is it? Look at me. Let's see, books. Swift Data Mastery. Yeah, Swift Data Mastery. Okay, so here, yeah, okay. So it is this one. So Swift Data Mastery, so this is teaching us SwiftUI and Swift Data, which is, as far as I can tell, and I looked at 15, 16 different sites dedicated to Swift. This was the only course material I could find that was actually up to date in terms of a SwiftUI first approach and a Swift Data first approach, in lieu of UIKit and Core Data, which are its predecessors. So not only is it a great book, very cool visual learning style, it's the only one I could find that was actually up to date as well in that sense. So we will come back, and on this stream for sure, I'm going to come back and purchase this SwiftUI animations mastery, because I just think it'd be really fun to master that portion of things also. Yeah, so I don't know. That's one reason that you should follow along, but yet another reason you should just come check out Big Mountain Studio just in general if you also want to learn Swift and don't want to wait for my pacing of it or don't like my flavor of it. You dig? All right, so now let's go back. Now, part of all this too is this is a learn along, I'm not instructing you, I'm not preparing course material for you. I'm using somebody else's material and learning it and inviting you to learn along, but we're not directly interacting. So that's another point you should be aware of. And also too, after we finish SwiftUI, this whole stream is an effort to build an actual product, started a company. I want to release, apps out on the marketplace under that company. So we are building an actual product on this stream. So this is a way to hold me accountable, give me a reason to keep coming back to it. But it's been fun, but it is in some parts work. So this has been helpful for me and cathartic to some degree. But anyway, after we finish SwiftUI, we will put together some schemas. So we're going to put together a GraphQL schema. So if you never experienced what that's like, now you can see it. Well, after a while, once we finish this book. And then we will also put together a SQL schema, SQLite, for the onboard storage of the app. So that'll be fun. We'll spend a few days on that. That'll be iterative, of course. And then after that, we're just going to start trying to build the thing. Just start hobbling some code together. This will be my first crack at this. I've never written a full-blown application. I've written, that's not small web apps that would kind of qualify, but never a full-blown product like this. So it should be a big-time learning experience. But I've never written an app before, like an iOS app. So that'll be a completely new experience. And I have this here because I'm certain I'll hit a wall sometimes, just in thinking about how to design the application itself. So on those slow days, I want to backfill with some C programming because I just think it's a tool that I want to have. I just want to be able to read it, easily read it, understand the paradigms around it, and then also, more importantly, learn how to use Swift to interoperate with C libraries, because that's another important skill I think that myself and others should have and probably want to have, because there's a lot of good stuff we can reuse out there. So as to not reinvent the wheel. All right, and then the app itself is called MRP Panda. That's not really important now. I won't bore you with the business aspect because we're going to talk a lot about that once we move on to the schema. So we can stifle that for now. But yeah, so that's the general idea of what we're doing here. So if that sounds good, then drop me a follow, brother. If not, get the hell out. All right, so now that's always my favorite part, telling people get the hell out. Now let me close all this stuff I was buying and get into Xcode. I see a sliver of... I'm still trying to master my green screen setup. I thought it'd be cool to have full body. No one's really doing that. Plus, I think it's cool. And I want to shoot some other stuff. Where I'm like falling in the sky or some shit. Something corny, but I think it's awesome. But yeah, that's the little flickers there. This chair I'm using they're basically transparent legs, so it's kind of odd the way it refracts light. I'll have to figure out something there, but yeah, anyway, nonetheless, let's get this open here. Now, a little bit of forewarning, this couldn't be mounted. Why couldn't it be mounted? Let me unplug this and replug it in. I don't think it'll break anything on the stream, I don't think. That didn't do anything. Did it? Now, why would that be? Come on, man. Okay. I guess it's just broken. Well, at any rate, we can still go through it. We don't necessarily, honestly, we don't necessarily need Xcode right now, although there is a helper project. So let me just download that quickly. And if you want to also download this, you can. Because I think anybody can get out there and get it if you want to follow along in that way. But most of it is visual. Book. Swift data. No, there was a... Where the heck? Oh, here it is. I created a code edit. No. Here. You know what? I just go to the website. Paya, there you go. I've used Swift Data Mastery. There we go. Okay. BD, how about that? Desktop. Xcode. All right, cool. So this has all the code. This code is already written, so it's a little different than what we did with Big Mountain, because in Big Mountain we hand keyed everything, which I think is good. But in this case, I mean, you'll see, it's very visual. I like the way that they lay everything out, so I'm not necessarily as concerned, because we're gonna get we got plenty of repetition for one, going through that 800-page book in Swift. So if that's what you want to see, you'll get plenty of that if you go back and start over from episode 1 of the stream. Otherwise, I'm just going to go through this as a visual, learn the concepts, look at the code if needed. But obviously, once we're done with this, we're really going to start putting pen to paper, so it doesn't really affect me in a meaningful way to skip the manual typing of the code, if that makes sense. But what I don't know is, let me look on the Windows machine here for a sec. Hopefully I can mute. Yeah, it'll let me just mute the stream, but I need to see the very end of the last Swift one I did to see where I left off. Okay, muted and oh, episode 40. See, I had some. Oh, damn it. I did. I fucked up the. Oh my gosh. I'll have to fix the title after this. This is not episode 40. This is It's way further along than that, but so it looks like 62 was the last one. And we left off on requery fetch. Okay, that's good enough. Just to know where I'm at. Requery and fetch. Which does sound familiar. Yeah. Oh yeah, because shit was about to get real. I do remember that. Sorting and filtering, query research. Yeah. Okay. All right, struct query, searching with requery, predicate descriptor, execute the model. Maybe we'll start back with this because I don't. This looks like, I think we did look at this, but we'll do this again just in case. Okay. Yeah, so we'll start here. So there should be some overlap between last episode and this one. The title doesn't make sense now, but it'll make sense after I end the stream. I'll update the title. Title 2, episode 63. Okay. All right, when it comes to requery, there are two methods you can use to create a new query to run again. Subview query, which has a parent view and a subview. The sort and filter criteria are selected on this view and passed into the subview's initializer. And then in the subview, inside the init, the at query, which is the macro, is recreated with the parameters passed in and rerun to return the models. Okay, so that's method number 1. Method number 2 is fetch. Just a parent view. The sort and filter criteria are selected on this view, and a fetch function is run using the sort and filter. The fetch function is equivalent to running at query to get data. The fetch function is equivalent to running at query to get data. Okay, I'm not sure what that means just yet, or what that implies. How do they compare as far as performance goes? They perform the same. They are fast and both scale very well for large numbers of models. Okay, are there any drawbacks to either of these? With the first one, you have to create a subview to make it work. With the second, you have to manually refresh the view if any changes are made to the models. You will learn the solution. Okay. So I guess on the one hand, or with the second, with the fetch, in lieu of the simplicity, or sorry, in lieu of the additional complexity of adding a subview, you run the risk of not updating if you don't remember to manually write your code in that manner, is what the trade-off sounds like to me. But I would still opt for, I just don't like sub anything. Sub anything, yeah, I just don't want to nest anything if I don't have to. Just like as a general rule, it's almost always a pain in the ass, especially to debug. It looks cute when you write it, but it's a pain in the ass to debug. All right, requery, subview query. Okay, so we're looking at the first method, which looks like this. So you sorted, then filtered, then turned off or changed the sort. And that's the example of a requery, subview requery. Sort, filter, requery. Okay. Requery because you're resorting. So same data set, different sorting. Okay. All right, to make the subview method work, you need 1, sort filter values. Okay, so our at state macro, I can't speak to exactly, but we know that it conforms to the identifiable and the comparable protocol. And because of that, allows, basically, like if you've ever written React, a lot of people have written, web pages, stuff like that, or any kind of similar framework like React, or not React, sorry. I guess, well, kind of. It's kind of like React's re-render behavior, the way that it re-renders each time that a view is invalidated. But actually, I think it's more like signals. Like if you ever tried, what's the name of that framework? It's escaping me. A lot of them have it now, but it was Solid. It's called Solid.js. Almost certain it's called Solid. But yeah, they use signals. And so down to the element, like the singular element within the DOM itself. So like an element would be like this title on any of these lists here, any single element or the text below it or the image. It can recognize down to the singular element if something changes or if one of its dependencies has changed. It somehow can identify that it's invalidated and needs to be requeried, rerun, and then you can get the updated binding in the view. So you're not recomputing the whole view itself, but you're re-rendering, recalculating. What would be the right term for that? I guess they call it requery, so we'll just call it requery. You're requerying the database or the data source and then building the updated view, which is, the element and then whatever the new data is that's associated with it. And so that at state corresponds to the observable on the other side on the caller. And that's what gives us that pipeline where SwiftUI is automatically taking care of that for us. So where am I at? I'm on page 128. Let me go back real quick because they had a nice little pipeline thingamabob that they showed us. This thing here. Yeah. It might be further along. Maybe pipeline. No? Yeah, try not to get sick, sorry. I could easily just stop and go back to the list, but I'm gonna stick with it. Keep going. It can't be that far back. There it is. So this is the general concept of what's happening. It's the pipeline concept. So kind of like, almost like, what you call it? WebSockets. Or, well, WebSockets being the underlying implementation, but promises, that's what I'm thinking of. Promises in JavaScript. Kind of like that. Like RxJS, you ever use those? Or if you ever use that framework. But yeah, whenever the view makes the binding to the backend into the context, when you first make the request, it establishes this pipeline. And so there's a two-way street between the dependency and the view. So if in either situation something changes or a dependency changes, then the connection is made and remains. So they're constantly talking to each other. So it's kind of like a fully aware state that can update itself. Or the framework can. But it makes it very easy. Easy to reason about, easy to think about. So if I go back to my page now. All right, requery subquery. Okay, so sort filter values, the subview to pass in your values to create a new at query. This was the part I didn't really, I remember seeing this and still, so maybe it's good I restarted here because perhaps subconsciously I didn't really grasp what it meant by that, making a new at query. Subview on the next page. Okay, so to make a subview method work, you need the sort and filter values. We got that here. So state to wrap the property. Sort order is equal to forward. And then filter on. So, and okay, so the filter is, that behavior takes a bool, so that's why we're just setting it to false. Okay. And then subview on the next page. In the stack, in the navigation stack, we have a park list view, or an instance of it. The sort order is forward, as we have defined up here, and then the other parameter, filter on, our value here that defaults to false. Okay. It's interesting because, I mean, a lot of this stuff we've already seen. It just wasn't explained in this way, so I guess... Well, I mean, I'll say for me, that's the more difficult part here is... having never written any of it, taking in the continuous explanation of what I'm looking at and trying to make sense of it, which I guess maybe I don't need to linger too long, because ultimately once we start building it, a lot of this stuff probably will be like, oh, okay, yeah, that was, you know how that goes. So, yeah. But yeah, I still don't get it. I still don't get the new at query thing, but we'll see. So you create a at query like you normally would, but then in the view's initializer, you use the parameters to construct your sort and filters to create a new query. Okay. Perhaps what would be good is, okay, park list view, we'll come back to just do a quick refresher on at query. So it's a property, a wrapper in the SwiftUI view. For this chapter, we're going to use this model that describes parks in different regions. Yeah, so we learned about model. Marks it as a model within SwiftUI. Otherwise, just a normal class. And we can also extend it. Okay. All the different ways you can use the at query. Okay. Well, actually, okay. Now I need to go and see just the flow in general, because it's pretty basic. It's just, there's a lot of nuance and like sub ideas within each, but whenever they explained it initially, it makes a lot of sense. So the model just being effectively your types and or your schema. Not the same thing, but kind of. Kind of, because there's going to be some overlap. Because ultimately the idea is that, or I guess that's true if you're going to have an app that persists data. And in my case, that's definitely the case. You know, it's going to be a application that revolves around, you know, SKUs, inventory levels, quantities, cost. So these are all very mathematical type things that will need to persist and have multiple iterations. So to me, at least, I can define model in that way, or think of model in that way, in a kind of overlapping kind of way. Then there's the toolbox, which is part of what Swift data is. So the container is really closer in definition to the toolbox itself, meaning it's the framework, it's all the tools that we have access to as developers through Swift, SwiftUI, Swift data, things of that nature. But the toolbox, or no, that's it for the toolbox. The playground would be the context, which is for a given running instance of the application, it's an allocated space in memory to interact with data from the application while you're running it. So anything that you're actively working with in the app, like even this slide itself, is in the context of Apple Books app right now running in memory on my MacBook. So it's well, I mean, quite literally the context. I don't know. Hopefully that resonates. But to me, context is a perfect description of what that means once I understood it. So that's just actively what you're working with. So not everything is in the context, but it's whatever you're immediately working with or loading from disk that you want to work with in the app itself would be loaded into memory, aka in context. So that's the playground, and then the view, of course, is what we interact with, we as the end user, what we see visually on the screen. Okay. And so as part of that, I suppose the query in this case, though, would be a function of the view, because we're going back and asking the context, or maybe I guess it reaches across both, because you could either be querying the main data source, or you could just be making a query to data that's already loaded in memory. And perhaps Swift data makes some of that easier by not forcing us to make those elections, but we'll see. But okay, so that's a good reminder for me, at least, to see just the general sense, get a general sense of what the fuck we're talking about. Okay, so that helps a little. Man, 5 days is too long. I can't take such a long break from at least not in the midst of or in the middle of a concept like that. Okay, so brother, okay, so okay, parkless view. As you sort, filter, values change. SwiftUI sees your subview is dependent on them, and so the subview is recreated. So yeah, this to me, like this example they're showing us would be an example of just requerying what's already in context, like in memory. So we're not going and grabbing more data than what was already there. We're just rearranging the data that we already have. So like at the start of the video, we have this entire list, which would mean it's already in context. Then we filter it. Then we change the sorting. Okay, yeah, that seems to make sense so far. All right, now parkless view. Further, yeah. So is that the same? Okay, it is the same. Oh, that's this. Okay, that's why they're saying that. Makes a lot of sense. So parkless view is being used inside the view here in the navigation stack, but now we're looking at the definition, the actual struct, parkless view. Okay. Phew. All right, you create a @query like you normally would. So meaning we just literally write the macro here. So let me go look at that first. Parkless. Whoops. Good, only one. Okay. And if I remember my shortcuts, Command, Option, Enter. Booyah, okay. Pardon me. All right, now make this a little bigger. How's that look? I'm all up in the code, brother. Uh, my bad. Maybe I hold on. There we go. It's probably better than I thought I had. There we go. For the grammars, I'm just moving the. I'll just leave it at line numbers. And just a hair bigger. Okay. All right, so now park list view. This is something. So we're talking about this thingamabob. So literally just a macro, but there's a way to expand this so we can see what it generates. No? Or was it control click? Oh, I think I have to. I have to run this. It might be it. Failed to build scheme. Oh, right. I don't know why it so it defaults to the device on board, but so we're just gonna do iPhone 15 Pro Max, brother. Control B to rebuild. What the fuck's the problem? Couldn't create workspace arena. Oh, right. Yep, my bad. I forgot. Yeah, I think I'm just gonna call this a dev machine straight up and just leave it and not use any drives and just buy a new Mac once, I don't know, life just forces me to, because it's just really, it's really fucking annoying to, it's just very picky. Not that Windows is perfect, but damn, like you can't. It's just finicky, I'll say that. But let's just put these all in the same spot. What's the worst that could happen? Okay, and then here, can I do it now? Okay, it's thinking about it. I know error while handling message. Okay. Close and reopen should. That trick is undefeated, so that should work. There we go. Yeah, I was telling Liv the other day, you know, so far, I mean, I mean, this is not great timing because we just had an issue with it. But you know, that was a user error, and I knew that. And this has happened before, so it's not like that was a big deal. But I mean, Xcode gets a lot of shit, you know. But I've worked with a lot of editors. I can't sit here and tell you that it's any worse than IntelliJ or IntelliJ Ultimate or Goland or WebStorm or Nova or Sublime or NeoVim, like VS Code. They all have a way of pissing you off, so I don't know. I don't. I can definitely see why a lot of people just land in the camp of like, bro, just, you know, defaults impossible, and yeah, I don't know. I just see no merit in debating about editors at all, because they all kind of do a good job of pissing you off and making your life harder in some way. But okay, so it looks like it's working now. So now can I expand? I just wanted to see the expansion to see the code. Option, I thought that was control. That's control. This is option. Command. There we go. Control, control, command, command. Okay. All right. Oh, no shit. I just got what that was doing, dude. That's awesome. So if I hold control and just move the mouse, I can move the window? Huh. I like that a lot. I wonder... Well, I won't belabor the point. I need to look into that, though, because I don't know if that's... I have this little third-party window manager. I don't know if that's what's doing it or if that's standard Mac behavior, but that changes things for me. I just, yeah, I need to remember to look at that. Hold. Okay, now back to it. Okay, so we're here now. Can I expand you now? No. Okay, maybe that's just some things, not all things. I thought you could do that. I wanted it to describe more what it was intending to do, but okay, I guess not. That's all right. In that case, let me just read through this. So, query private var. All of this we've seen. So private keeps it, meaning nothing can edit it. It being the var parks, unless it is from inside the scope of. So like the initializer could. And it looks like that's about it in this case. So yeah, that would be the only way to get to this particular one. It's of type an array of park models. Here's the initializer, which is required to be here. We can't use the implicit likewise initializer that the compiler would create for us if this was just regular old Swift. But since this is SwiftUI, it does require that we explicitly write out the initializer for it. So we have two parameters, sort order and filter on. Sort order will be of type sort order, which is that a protocol or what is this? The orderings that you can perform. Actually, we know it's a protocol just because of the syntax highlighting. If it's a protocol from the SwiftUI library itself, it's pink. And then all of our custom defined stuff, it will be this green up here, like park model. So we do know it is a protocol. Okay. So I won't dig into that. And then this will be of type bool, so true or false. So that holds up, so that makes sense. And then in our body, we have a constant called sort, and that's equal to sort descriptor, which we learned you have to pass this in as an array and then use this sort descriptor. What is this? What is it, a method or what? It's a struct. Okay. So we have to pass in an instance of sort descriptor whenever we want to use multiple sorting properties. Otherwise, it would look a lot more simplistic. Like it would just be parkModel.name. But since we want multiple, we use inside of an array sort descriptor, and then we wrap the parameters. So in this case, we're sorting by these two, parkModelName and order, sort order. Okay, and then another constant for filter, hash predicate, freestanding expression, macro, predicate, each input, anonymous parameter, body, repeat each input, bool. Oh, it returns a bool, true or false. So repeat each input, return true, false. Oh no, that's the signature of the body. So that's a closure. Takes a closure as an input. Returns a bool. That closure does. And then the function itself will return a predicate. Okay, yeah, you lost me. You had me here. I know what this is. I don't. What is a predicate now? It goes deep, brother. Okay, so maybe we'll wait because he'll probably explain that. I just wanted to see if I could make sense of this code. So to some extent, I get what it's doing. This constant is equal to an instance of this predicate, and then here's a trailing closure syntax. So for each arc model, wait, that's a generic with the pokey syntax. So we take the predicate and then apply this logic, basically, is about as best I can do right now without knowing what that does. But for every value, so park is our iterator, we want to return true or false based on whether the country attribute of park is equal to United States. So if it is in the United States, true. If not, return false. And then underbar park, so we learned... Oh, that's right, I do remember that. So in Swift, general Swift, the leading underbar normally would just mean that it's a private, kind of like this is saying this is private here. This would be by convention, a way of defining that. But we almost want to throw away that knowledge because we also learned, subsequent to that in SwiftUI, which in this case we are talking about SwiftUI, underbar parks is of some significance. So it's like a shadowed value. Now I'm remembering. So that was pretty trippy. So that's why I was kind of struggling last time. So yeah. But he did cover this. So yeah, I want to go look at that now because I remember trying to reason about that whole issue. Oh, here's predicates. Yeah, okay, see, this is First, let me just find, can I surely there's a find. Okay, yeah. What do I want to look for? I want to look for oh, I'm a dummy. I'm staring right at it. Okay. This is... Yeah, this was it right here. Underbar park. So this actually means something in Swift. What is underbar parks? Or this actually means something in SwiftUI, where it is only a convention in general Swift programming. So, yeah, it matters. So if you're going to be a SwiftUI dev, and you're going to use SwiftUI first, which that's where everything's going anyway. So we're just going to make that assumption from now on. So for purposes of not being confusing to myself or anybody else, from now on, I will no longer speak of what we learned from the Big Nerd Ranch, and instead I'll just refer to whenever we see an underbar. If I happen to mention what it does, I'm going to use the context of SwiftUI. Fair enough? Okay, great. All right, what is underbar parks? The underscore in front is what gives you access to what Swift calls the property wrapper. The property wrapper's stored property. It is the underlying object query as opposed to park model. It's way up here, brother. I don't know. But we'll get there. Okay, so query as opposed to park model. So it's the query as opposed to the array of park models. I guess. I guess it kind of says it right here. Equal to literally a query. Ah, man, my fucking head is gonna explode. So okay, so query is a thing, and then at query is a thing. Okay, so let me click on that first. I'm curious if this fetches all instances of the attached model type. Okay, that makes sense. Fetches all instances of the attached model type. All instances. All instances. I guess in our case, we only have one. And the attached model type we know is park list view. Or sorry, park model. Yeah. Oh, no, not all. Okay, so we don't necessarily know that, but it's an array. So it might have multiple instances, sure. Okay. So it's going to fetch everything, all instances in the array of park models. Okay, it makes sense. But what is query? Is that different? It is. So there's the macro at query, and then there is this struct query, which has this initializer that requires that we pass in a filter property or a filter value, which in this case is a generic predicate element optional. So it can be nil or could possibly be nil. And then a sort in a transaction, which I don't think we've covered yet at all. Ooh, not tired, you're tired. A query, a type that fetches models using the specified criteria. A type that fetches models using the specified criteria and manages those models so they remain in sync with the underlying data. Say that again. A type that fetches models using the specified criteria and manages those models so they remain in sync with the underlying data. Type that fetches models and manages those models so they remain in sync with the underlying data. Okay, I mean, that makes sense because if we look at, I mean, because that's what's happening here, right? There's a model, the park view, or what's it called? Park list view. So that is itself a model. And the query is grabbing the data, and then as we filter and sort, keeping it in sync. So meaning the context, the raw data that makes up the context in sync with where that raw data goes within the context of the model itself. So it's very granular, but I mean, I think that's what most people would expect a framework that handles your data bindings from your visual component to your data component to do. So I think that it's just being very explicit in the explanation, and now it makes sense. Okay, so I really do think that makes sense now. Okay. Just give my brain a second to expand, brother. Actually, I'm gonna hit the loo real quick. I'll be back in what time is it? Oh, whoops, I didn't change. I should probably do that, eh? I didn't change my Twitch. Category. Now they're gonna yell at me. Matter of fact, let me do that real quick, and then I will. Producer, manager, edit stream. Software and game development. My bad. Yeah. Oh, whoops. And on Kick, I suppose. So, let's see. Swift and episode 63 and software development, not explicitly 18-year-old material. Oh, hey, viewer on Kick. Hello, brother or sister. Love you. Okay. All right, so now I will be back in a short amount of time. I'm gonna go hit the loo. Okay, BRB. Tuck your chain in, player. Tuck your chain in. Good. You know what's stupid is, well, maybe it's not stupid, but whatever. I think it's silly that Instagram limits you to an hour-long stream. I mean, if the issue, well, I don't know, whatever, doesn't matter. Oh, I literally just crossed an hour. Yeah. Oh well. Reconnecting. Streamlabs is just so confusing because now I'm paranoid. I gotta go see if, I think I'm still going, but let me make sure real quick. Says I'm live. Well, if that's what it says. Okay, so let's get back to it. So then, where were we? Ah, yes. What is parks? The underscore in front is what gives you access to what Swift calls the property wrapper's stored property. Sorry, I just had to take my vitamins and store. It is the underlying object. Query as opposed to park model. Okay. So query in this case is an object, and we can, we're led to believe this because why? I'm not sure exactly, but no, in reality this is why. So it's no different than any other object because it's just a struct. But what I think I would like to do is just have a large language model validate that. So I will word it in a way where it should tell me exactly what I want to hear in the context of a SwiftUI. What is the difference betwixt query and okay, so that's a good first important it's important. It's an important point. You know what I should start doing is I mean, it's too late now, but I should put on the vertical. Yeah, that's a good idea. I should do that. Matter of fact, I'm gonna do it right now. Or no, I'm not, but I'm gonna have a note here. Add in stream our warning to Insta stream. Okay, so first point of note, query or at query and query are both parts of Swift data. And I think what I'll do is add a note. Really? I mean, come on, bro. So pointless. And now it made my shit. I gotta be honest with you know, I paid good money for a Qbox, but it hasn't been like freaking awesome. I'm not gonna call it awesome. Did it save it? It just takes me back here, but can I see it in the app? And I don't. Bitch ass PDF. How did that get in there? What? Whatever. As long as these are up, but this isn't gonna work in terms of. Come on, bro. That shit's weak. Capture selection menu. I don't know what I feel about that. Share and export. Ooh, you know what? I'll do it like this because you know what would be good? I can share these with you guys after the fact. Since I have a Replit account, keep all these code samples and just share these. Ooh, that'll be cool. I don't think anyone else is really doing that, brother. Come in here, collab on it, you know what I'm saying? Yeah. Who else is doing that for you? Someone else might be, I don't know. But that's a good idea, so I think I'm gonna do that. And then I can just group it by, yeah, it knows it's Swift, so yeah, okay, that's not a bad idea. It's not a bad idea. All right, so now let me cut this off here. I don't need all that. I just need to finish this out. So, all right. So they're both part of SwiftUI. The @ query, the property wrapper. Its purpose, this property wrapper is used within a SwiftUI view to fetch and observe data from your Swift data model. Automatically updates your view whenever the underlying data changes, ensuring a seamless user experience. You typically define a query property in your SwiftUI view to retrieve a specific set of objects from your data store. You can apply filtering, sorting, and other criteria to refine the fetch data. Okay, so we're simply wrapping whatever object we would want to continuously update in a given view. Makes sense. Okay, so that's a wrapper. And then there's a type query. Purpose, this is the underlying type that represents a Swift data query. It defines the parameters of the query, such as filtering and sorting. Okay. While you often don't interact directly with the query type. Oh, I see, you don't. Okay. Well, that's good to know. When using @ query, it can be useful in more advanced scenarios where you need to fine-grained control over your data fetching logic. You can create a query instance and then pass it to methods like fetch query. Oh. Okay. Then okay, now I wish I hadn't closed that replit, but that's not a big deal. I just want to see if it also does it also pass in the notes, because that's it does. Look at that. Fucking A. You know, every time I, because there's been a few times where I defected. I was an OpenAI user or a ChatGPT user. You know, I was happy to pay the $20 for you know, the pro features because they're nice. Like, for one, the app was probably the best part, being able to use the voice and all that. But then that became free anyway, and then I found that I was really using a lot of tools that use the API anyway, not so much the direct web app. Anyway, so I switched because then I found out about, you know, all the bullshit they were doing, and I don't necessarily want to enable that, although to some extent I think we're all going to get fucked in some sense, and it's unavoidable. I don't think it's going to be nearly the cataclysm that people describe it as, because people just don't understand what AI is, and it never should have even been called. AI. It should have been called, predictive text, but that was already taken, so they just said, hey, we'll just hijack another term that's already out there, AI. I call it AI, but whatever. I digress. My point is, I just don't fucking like Sam. Like, I think any of these people, like, to me, the more, a lot of times, or for many years, I think Mark Zuckerberg of Facebook is Meta, sorry. Basically, I think the more he speaks and shows his face, the more people hate him. The more he just falls back and does CEO things, even though he probably, as a person, is not really changing, But just stop trying to be Elon. I think that's the thing. Stop trying to be Elon. Not that Mark is, I'm just saying this is my reasoning for why I don't like Sam. I feel like Sam is just put on a little bit. He enjoys a bit too much just trying to be in the spotlight. And it's fucking annoying, and I don't like his face. That's all I can really say about it, but I think that really is the reason. Because otherwise, I don't think Google is somehow more altruistic than OpenAI, which is basically Microsoft at this point. I just don't want to see your fucking face talking about it all the time, talking about how you're breaking ground when it's so clearly just, dude's talking like he's building the fucking Matrix, and I find him to be a liar. That's all. Okay, so query type. This is the underlying type that represents a Swift data query. Okay, yeah. So that's a good point here, because now I can understand. There's a base query that wraps around the code itself. So we're wrapping this property here, an array of books. The query itself, though, we can change. So normally this would get generated for you based on the object, but if you wanted to specify the filter or the sorting logic for a given instance of a query, so you're still querying the books array, but you want to do it in a different way, you can modify that object similar to how we can have different properties for, structs or even enums, stuff like that. Okay. So the query is just the object that contains all the information about the model, what you're querying, and how you want to return the view. But the fetch is the actual action. So you pass a query to a fetch, is what I'm perceiving here. What I'm perceiving to be the truth here. Okay. Is it common to access stored properties? Not really. I expect Apple will change the way we can do dynamic queries in the future. Okay. So maybe we don't need to focus on this for too long. Requery fetch. So now we're here. As you change sort and filter state values, the body is redrawn and the computed property, filtered and sorted parts, is called by the list. So because we're changing the fetch, or the query passed to the fetch, everything that's using it gets invalidated. So this filtered and sorted parts is here in the list. It gets invalidated when we change anything about the base query and it's rerun. The model_context.fetch function is useful, as you will see later in this book, but it will not update the view if models in the context change. See the next page for the fix. Requery fetch refresh. Okay, so what is this now? So we filter, we add a record, and that's it. Filter, add a record. All right. Okay. Add a at state property. Add a, oh, okay. So now we want to observe, we're adding a value to dictate a true false on a value called refresh. Then we change the state property when there are model changes. So as part of all this, now we're having this. So I guess this would be the manual part. So we have to call this refresh.toggle. And we can do that because it's a bool, meaning we can do the toggle. And then when the ID property changes, the view is updated. Okay. I mean, that makes sense, yeah. @query has the benefit of updating the view when models in the context change, but the fetch function is simply read-only and will not update the view as models in the context change. To trigger view updates after you make some model changes, insert, update, delete, you can use the ID modifier. When an ID value changes, the view is updated. You will see this technique used again later in the book. Yeah, that's weird. Or not weird, but even an older, like in a past life working for a company that had a Fox Pro app, they would also do this. So I guess that's carried forward for many old technologies. Just that whole concept of, I don't know if you call that a workaround, but just that's the technique. It's always refresh the ID. That's interesting. All right, summary for dynamic sorting and filtering. So I need dynamic sorting or filtering, and I have two different ways to do it. So either in memory, fast for a smaller number of models, and better for filtering or sorting data already queried, because it'd already be in context, which is in memory. Or we can re-query, fast for a larger number of models, better for fetching new data based on filter and sort parameters. Subview query method. Oh, I see. So in memory or requery from source. And then beneath requery, there's the subview method or the fetch method. Better for displaying read-only data. Better if making changes to models, because it automatically updates the model context and refreshes the UI. Okay, so let me look back at that. Maybe I am wrong about because that kind of seems like less of a headache, the subview, because it's not that big of a deal. It's the view, but then you have parked list view, but you would just define that elsewhere, which would just be a struct. I don't know. I'd probably lean towards that, honestly, as opposed to this. As models in the context change. So if you're letting them add properties to it through some interface and forget to implement this, you could really get some fucked up problems, because they might, yeah. That's weird. A lot of these problems are still go unsolved. I don't know. It's just a lot of you see a lot of the same issues come up just from the years of hearing customer reports. But hey, it's all built on OOP, so I guess it kind of makes sense if it's following that paradigm. Okay, so query with searchable. Apple uses the search feature on list in two scenarios. The list already has data and the user is filtering that existing data to find something. The list has no data and the user is doing a search or query to find matching data. This section will show you examples of both. Searchable filter or search. Filtering and searching with searchable are different concepts or flows. This section will cover both scenarios. Filtering flow. You start with data, narrow it down with filter text. Note, only one query is performed. Okay. So when you filter, narrow it down with filter text. So kind of like, okay, so that's like a leading search, seemingly. Then searching flow starts with no data. User enters. Oh, okay. Yeah, okay, I see. So the data would already be there. And then you apply the filter. So that could be leading or not, but the case would be that you already have the data. And then here, this foundation has no data. We enter some kind of key term, hit enter. Now you return data. So I guess you're actually using that value, you pass that in through and somehow or another that gets to that fetch function. User enters search text to get data. A new query is performed with every search. Yeah, okay. Which is, well, so it's interesting in the sense that if you had, like, this second method could apply, well, whatever, it doesn't matter. But I'm thinking you should warn people in the sense that if you're talking about, no, what am I trying to say? I think the implementation here, when it talks about search, since so many apps now are, running on AWS effectively, if you allow your users, just as an example, to run many queries and you don't have like a cache there to kind of stop all that work that it can do, you could potentially be losing your hat just because you're allowing the end user to control how much work your server is doing. You know what I mean? Like, it can just keep launching query after query after query. In memory filtering with searchable. Okay, so this is existing data. Yeah, leading search, or what we would, as end users, identify as leading search. Reacting to each new character typed. So you start with a query that has no filter, so all results are displayed. Okay, so that's what we're used to seeing, pretty basic. And then a new query is not being performed. You are only filtering what's already been retrieved. If you want to limit what you are querying first, add a predicate to the query. If you want to limit what you are querying first, add a predicate to the query. And that's a predicate? Parks.filter, park in, park name, localized case, filter text. I kind of get that. Pass a predicate. Model. Okay. Searching with searchable using requery. Okay. You will need the model context to do a fetch. Environment. Private var model context. As the object. Create a predicate. So this is the predicate itself, generic. An array of search text part in or region or country. Oh, okay, I see. Kinda, yeah, okay. So you type in United States and it would check the name or the region or the country for those. Add them to a fetch descriptor. I'll create a sort descriptor. Add them to a fetch descriptor. Here. Predicate. Sort by. Execute a fetch using the model context. And then return try because we want it to crash if it doesn't successfully retrieve model context.fetch fetch. Oh, and there's fetch. Oh, okay, yeah. Fetch, and fetch is the fetch descriptor with the predicate so that filtering happens on the back end, in theory. Okay. Every time the search text changes, a new fetch is done. Okay, this is the same way you created mock data for park row view. Now that you know about model context.fetch, there is another way to get mock data. Okay. The advantage of creating the model is you can test with custom data you set here. But creating the model is the advantage of the fetch is it is a lot less code to get the mock data in your preview. Yeah, what was that other stuff? It's quite difficult to follow. Search logic options. In the first example, all the parts are broken down into separate pieces. The shorter example starts by calling the fetch first and then creating all the pieces as needed. Notice where the park model type is specified on each. Either way is fine. I just wanted you to have examples of how this fetch can be put together either way. Okay, so longer version. Here's the predicate. And the or, let, return in the shorter version. Return, try, model context, fetch. Put the descriptor inside the fetch, which has the predicate. Oh, and here, okay, so that whole closure is the predicate passed directly in as a parameter of the descriptor. Okay. Okay. Animation parameter. Okay, well, I think maybe we will hold it. Not maybe, we will cap it off there for today and pick it back up tomorrow because my brain is sufficiently fried. I see 2 people have joined. What's up, guys? Welcome in. Please drop me a follow and we will resume tomorrow now that we're back up to speed. That actually did make more sense though, so I'm glad I went back and covered that because yeah, I was not catching the drift the first time, but now it makes sense. So we'll pick it up here with an animation tomorrow for a couple hours and get back into the groove of things. So guys, I will be back in maybe 30 minutes, maybe less, to start my Halo stream if you want to check that out. Otherwise, do drop me a follow. Appreciate you coming. Don't forget to hydrate.